Hey, what's going on, guys? Negamax here. Last video we did have a look at brute force Negamax search, and this time we're supposed to have a look at what is known as the quiescence search. So the idea behind quiescence search is to evaluate behind the depth, the horizon given by the fixed depth to our Negamax search function. So before we will start writing some code, I would actually like to connect the engine that we've created in the previous video to the GUI to give you an idea of how it works in particular at this current state, and then we'll just add this quiescence search functionality and see what's gonna happen basically. So here is the source code that we've created in the previous videos. So we get the very basic brute force Negamax framework with the best score here. So we just associate the best so far move when we got a better move, and then eventually we just return, we just associate the best move that we're supposed to be making on board, also keeping track of the maiden score. So it's pretty basic stuff here. So I just want to open the terminal in the current working directory, and by typing make I compile this stuff, and we get this chess binary executable being compiled here. So if I just go to my arena and choose the engines tab, and then go to install new engine, and now go into the tutorials, Negamax and this quiescence, so right over in here. So we got this binary executable. I just want to open this. Okay, I'm happy today because it seems to start this engine by default, but there is some issues with the country, so let me just try to manage the engine and pick up some right stuff here. So I don't really want this Russia because I'm not from Russia, I'm from Ukraine. Also, my name is not like this, my name is Negamax. Okay, and yeah, the source seems to be just pretty fine, so we can just apply this stuff and try to go for a new game. Okay, maybe just going for a new game again. Okay, don't play please. Let's go for a new game again. Okay, so still the country is not right. I'm really sorry guys, but I just don't really want this Russian flag to appear around. So again, manage engine and country. Can I make it explicitly to Ukraine? Just wondering. Yeah, seems like so. Try to apply this. Okay. Well, I'm not sure if this is supposed to be working. I have no idea why he used this Russian flag. Let me just try to reload my arena. Probably this should help. Okay. Yeah, now it's much better. There's no flag there. Okay, perfect. So at the moment we are at the depth of 3 plies or half moves. So we just make this engine play versus itself. Okay guys, I'm sorry, just have a call phone. Hold on a sec. Just hold on a sec please. Okay, I'm sorry guys. So it seems kind of to play quite pretty normal chess, assuming the very basic evaluation function that we have there. So it's quite pretty solid for that sort of an engine, and assuming that we don't have any alpha beta cutoffs here, so just the bare Negamax search without quiescence search, please note. So what I want to show you here guys, that if we have a look at the game being played at the level of only 1 ply, and also bearing in mind the implementation of this Negamax search, obviously this whatever side won't be able to actually to mate the opponent, because in order to mate the opponent we need at least 2 ply depth search according to the current implementation of how it is done basically within the source file. But still, I just want to give you an idea what a weird game it would be without a quiescence search. So you see, like, black has just gave up a queen, and they really thought that they would be better, believe it or not. So let's have a look at this game. So here black kind of captures the pawn, and it seems like it's his pawn up, he's better, right? And now then white just goes for some sort of move, and black can only see that he can grab another pawn, and he can't really see that he will get his queen captured in return. So he goes for this, and he thinks like, okay, I'm 2 pawns up, plus 2.40, that's it. And he can't see any responses from whites. So in other move he just loses the queen, and he gets completely smashed here, but he can't really see this. So this sort of an issue is known as the horizon effect. So the horizon of surge depth for the black pieces is only one ply. So he can see, like, he can capture this pawn, and he thinks, like, after, so he just gives back the static evaluation of this function. He says, like, okay, so I'm just better, I'm just a pawn up, so I have a better material, I have a better position. So he doesn't take into account that his queen is going to be captured back in return, and that's the main issue here. So the quiescent search is a way to avoid this weird sort of behavior of the chess engine. And obviously you may just try to increase your search depth and things like that, but still anyway the horizon effect will work on whatever depth. So say this is not the depth 1 but the depth 4, so black will think absolutely the same, that he just captures the pawn and he would be the pawn up, and he won't see that his queen would be captured back in return. So this is the real issue here. So I hope that the problem is quite pretty clear here, and I was supposed to be solving this using so-called quiescent search. So I just close my arena for now, because we need to restart it anytime we make some updates within our chess engine in order to see the changes within the GUI. And let's go back to our search part within our chess engine framework. So what I want to do here, I just want to define my quiescence search here. Okay, and I just want to create the function called quiescence here, and this would be a void function. So sorry, no, not void, it would be obviously integer function. Obviously it would be returning some score. I'm sorry guys, obviously this would be integer function, but it's not gonna take any arguments here. It could take the alpha and beta arguments in case of alpha beta pruning, but as far as we're working with the bare Negamax, we don't really need to make use of this alpha beta stuff. So I will first just grab the entire code from our Negamax search, and then I will just get rid of unnecessary part and add some critical lines of code that would actually make this quiescent search kind of working. So but before that, let me just try to again, like, describe the escape condition. So I just want to describe the escape condition here. Escape condition. So if this was an alpha beta search, we would return on beta cutoffs, and that's quite pretty clear. But as far as we don't have any beta cutoffs here, we need some sort of another way of an escape condition. And one of the easy ways of doing this is just limit the quiescent search by a given ply. So if I just say something like if, and then this global ply variable say more than 3, so we would be looking up to 3 captures, not full bandwidth, but just the capture moves. So if we have this, if we have more than 3 plies, then we just return back. And here a couple things to do. So first we want to increment our nodes, and that's needed just for the statistics. You can drop this if you're not interested in calculating the nodes, but as far as we're supposed to be calculating the number of nodes traversed when we would be implementing some optimizations for alpha beta search. So I just keep track of nodes anyway. And here we want to return static evaluation like this. So we just return evaluate position that gives us positive score for white pieces, positions, oh my god, position that will give us the positive score for the white pieces and the negative score for black pieces, as it states here within our evaluation function. This function is very basic. It just evaluates the material and uses the only single positional score array for all the pieces. It's a really poor evaluation, but still, as far as we're working on search, not on evaluation, and we're trying to optimize the search and to make search kind of work better, it doesn't really matter that much like how exactly he evaluates that. Just this positional scores just serves the idea of just serves the purpose of giving an engine an idea of where exactly to develop his pieces. That's kind of it, and both in the opening and in the end game as well. So you can feel free to have a look at this positional score array. It's available in the top of the source code. Okay, so as far as our escape condition is done, then we can move for implementing the main part. So I would probably just grab this entire stuff here, so everything up to this best move, because we don't really want this. Okay, so just copy the entire stuff, and then just oh, what am I doing? Oh my god, what am I doing here within the question search? Obviously, I just paste this in, and now let's see what we need and what we really don't need. So we definitely don't need this best so far move, because we're not supposed to be associating the best so far move within our question search. Also, we don't need to count the legal moves, well, at least for now, actually. And then let's see. So as far as oh, snapshot has a typo inside. Snapshot. Whoa, it had a typo. Oh my god, this is not really that great. So let me just check. Let me change this typo. Well, I probably would also want to make the same in. Sorry guys, just want to update my source before I forgot that completely. So just the initial Negamax search. Let me just quickly try to change this snapshot. Okay, here. Okay, sorry. So yeah, let's get back to our questions. So we need this. Okay, so hold on a sec. We're not going to initialize our best score like this, so I'll change this later on. So we're generating our move list. Okay, perfect. Then we're generating our moves. Okay, then we're looping over the moves, just like in the bare Negamax search. Okay, initializing the move. Don't forget to increment apply, decrement apply on the illegal move. Okay, we don't need to keep track of illegal moves as well. Okay, so score would be calling quiescence search, and no depth is needed because we have apply based escape condition there. Okay, here we don't, so we only need to associate our score, and we don't really need to do anything with our best moves. So this is literally enough to make it like this, and eventually we want to return the best score, obviously. So return best score, save. Now I just want to make sure it still compiles, so to make sure I didn't make some typos. Well, I didn't, which is quite pretty interesting. So I usually do some typos, like missing a semicolon or things like that. Okay, so one of the very essential parts. So instead of all moves, we need to make only captures, and remember that the all moves and all the captures just the bare flags. So all moves equals to 0, while only captures equals to 1, and this is the flag that actually flags the make move function to make only captures or all the moves, depending on what kind of flag has been passed within the make move function. The other implementation could be just generate all captures if we have that function, but just for simplicity I decided to avoid using the generate all captures. So I have the make move level distinguishing between the quiet moves and the captures. Okay, so the very last thing we need to take care of our best score here. So first we want to get static evaluation and just create the integer called eval, and it would be equal to evaluate position, and now we need to make one little thing, one very simple thing here. So we need to say if and the best score is less than the this static evaluation. In this case, we need to say that the best score is actually equal to our evaluation function, like this. So here we just simply need to update best score, and obviously, yeah, it seems like as far, yeah, we also need to actually define our best score. So obviously best score, and here this integer best score variable equals minus infinity, just like it happens within the Negamax search itself. Okay, so let me check this one last time, and if I did everything correctly, from now on it really should play absolutely different chess at the ply 1. So let's have a look if we do succeed actually. So okay, not only capture but only captures. Okay, and okay, missed some semicolon before if, it seems like. Okay, oh my god, also this is wrong. Evaluate position and the semicolon after. Okay, now it makes. So let's go back to our, oh, not the system monitor, sorry guys. Let's go back to our arena, and so I don't need this folder anymore. I just want to invoke my arena, and if I did everything correctly, I just really hope to see that at the level of depth 1, it should stop giving away his pieces. So let's have a look basically. Okay, so probably I missed something. Just hold on a second, I just need to check one little thing here. Okay guys, so yeah, everything actually it should work correctly. The only issue here, so let me just close this arena. The only actual issue here that I forgot to, yeah, within the Negamax search, I just forgot to switch this evaluate position to calling the quiescence. So the quiescence routine itself seems to be working perfectly well, so quiescence, but I just forgot obviously to call this. So this is the main idea, like when we reach the horizon within our Negamax function, we then just call our quiescence search to make sure that we return the static evaluation only in that case when in theory we'll reach the composition that doesn't have any forcing captures. But assuming that we don't have any alpha beta prime in here, and it might take really lots of exponential number of moves in order especially in the middle games, in order to get this in order to process all the possible captures, we just limit our quiescence search artificially by specifying this condition. If the ply is more than 3 moves, then we just drop back, and this is just an experimental value. You can play around with this. So if you just make it too big, it would be quite pretty slow, because nobody uses quiescence search without alpha beta framework, to be honest. So I just want to show you like the proof of concept of how it works, or rather than some sort of a production. So the next videos we're going to be implementing the real alpha beta framework, and the fail hard framework in particular within the alpha beta. I'll describe what that means in the next video, and then we'll make the proper quiescence search to fit that sort of a Negamax algorithm. So I just want to make this again. Okay, I did misspell quiescence again. Yeah, it's time to learn how the quiescence is spelled correctly. Okay, yeah, now it works. So I just hold my breath and trying to run the arena one more time, and I really hope that it should actually start making decent move even at the depth of 1. So let's have a look. Okay, perfect, and you see, like, now it doesn't give away the pieces anymore. Instead it plays quite pretty reasonable chess, even though it doesn't castle and things like that, but still it kind of makes that quiescence search that lets him play like almost like a real normal chess. So this is kind of it. So I just stopped this. So the concept has been proved here, and at the very end of this video I just want to play one more game with this versus this Negamax algorithm empowered by the question search at the depth 3, just like in the previous video. So let me just adjust my level to let's go to depth 3, because at depth 4 it just plays some weird move. So depth 3 is the most appropriate one. It goes for the same position, but the same development ideas, but just I think it's slightly a bit different. So let's try to play some chess versus this guy. Okay, so I want to fianchetto my bishop. Well, he moves quite pretty strange already, to be honest, but okay, let's play c6, trying to ask this bishop go away, asking this knight going away. So okay, oh my god, why did he hold on a sec, something weird has happened. So yeah, I guess, whoa, it's a bit unclear why he sacrifices his bishop. This is a bit weird, to be honest, but well, this is really weird. I have no idea why this is happening actually, but let's keep playing basically. Yeah, probably I'm clicking this too fast, and yeah, he kind of like just doesn't respond properly to my clicks. I guess that's the reason, but still you get the idea. So well, I have no idea why did he give away his bishop there. So okay, let's probably he wants to mate me somehow. Okay, let him allow maiden me if he really wants this. So it doesn't seem like he's going to mate me. He's going for a draw. Well, not bad, not bad. Okay, so let's try another game. Well, let me try to play black pieces this time and go in. Okay, hold on a sec, hold on, no demo, just make a move. Whoa, this is interesting. So okay, let's play e5. Let's exchange stuff here. Well, this early queen moves doesn't seem healthy really. Well, but he finds he's pretty resourceful here. Oh man, did I just lost a bishop? Whoa, now this is really interesting. So he just won a bishop, which is really good of him. Okay, so it's really good of him, I must say. This is fantastic. Okay, exchanges the queen, not that bad. I'm wondering, is he gonna capture on a peasant square? Yeah, perfect, just perfect. So I just want to show you guys that it's already slightly bit different chess compared to what we had in the previous part, to be honest. So just to give you a rough idea of how this is kind of working. So yeah, let's give him a check. Okay, whoa, well this move is a bit unclear to me. Why he captures this is a bit unclear really. This is really unclear, really unclear. Well, maybe he saw something there that I didn't see, but still, oh my god, he just mates me. Oh man, yeah. So not bad at all for him, not bad at all, especially assuming that this was only the depth of 3, by the way. So this is it for this video, guys. I just wanted to give you an idea of how the engine's style of play differs from the between the bare Negamax and the Negamax that involves the question search along the way. So I hope you learned something interesting out of this tutorial. Thanks for watching. Until the next time, and take care.